Assalamualaikum warahmatullahi wabarakatuh. My name is Aina Dia binti Ali Suhairi. My metric number is AD1800060. As the abstract, for this assignment, we generally need to identify the best properties of materials in high-speed train brake spec. We discuss some materials that are relevant to this topic, which are cast iron brake shoes, copper brake shoes, and aluminium MMC based brake shoes as well. We did some comparison for each materials in terms of wear resistance, tensile strength, thermal resistance, cost, and coefficient of friction. So from our research, we found that cast iron is performed the best compared to the other two materials. Cast iron is the best material used to produce the brake pads for high-speed train to enhance the friction materials reinforcement. Other than that, cast iron is also deliver a great performance in wear resistance, which will make it last longer than the other materials, great performance in tensile strength, which makes it a great resistant materials, medium in thermal resistance, which is good enough to hold a heat cost by friction, low cost, which is economically good, and medium in coefficient of friction. Thank you.
Hi, my name is Nafis and today I'll be talking about the introduction. So, high-speed train refers to the train that moves faster than other train. The minimum speed for a train to be called a high-speed train is 250 km per hour. This means that a train needs to move faster or at least 250 km per hour in order for it to be classified as a high-speed train. About the braking system is in a moving vehicle is an application to slow or to stop the moving vehicle. This occur when the kinetic energy of the train is converted to the heat energy due to the friction from the brake pad and the wheel of the train. Because of the high friction between both wheel and brake pad, the brake pad material or properties needs to be resistant to heat, water, oil, have a low wear rate and high thermal stability, and also exhibit low noise. Why? Because when two things friction, and it will produce a very stingy noise that can hurt our ears, and that's why we need the material that exhibits low noise. For the heat resistance, when the friction happen and the heat is produced, if the material does not resist to heat, it will be defect and accident can happen. That's all for me. Thank you.
For problem statement, in Malaysia, we don't have high-speed train yet, so it's kind of difficult to find the problem regarding the brake pads of high-speed train because we don't have it yet in Malaysia. So we can only assume the general problem that may occur if we were to have it one day. So choosing the best materials to produce high-speed train brake pad is one of it. One of the most important components in high-speed trains demands are improved on the mechanical and tribological properties of materials for brake pads, quote by Yelong Zhao and Zhongyi Zhang, year 2017. So, the material properties of brake pads are our main focus of the problems that need to be studied for us to choose the strong and efficient brake pads to be used here in Malaysia. For objective, the purpose of this assignment is to study the best properties of materials in high-speed train brake pads. This research is conducted to find the best materials that can generate great and strong brake pads for commercial use here in Malaysia. The finding of this study may help in finding the finest friction material reinforcement that will generate a great high-speed train brake pad. In this study, it is 100% based on journals, internet, books, articles, and researchers' theses. The outcome of the study is expected to be useful for the future of Malaysia high-speed train brake pads. So the objective of the study are, number one, to determine the best material used to produce brake pads for high-speed train to enhance the friction material reinforcement. Number two, to compare wear resistance, tensile strength, thermal resistance, cost, and coefficient of friction on clean and dry condition of main materials. Number three is to select the final main materials that has more advantages than the other material based on our findings.
Assalamualaikum. My name is Ali Lukman bin Alinan, AD180146. So my part is discussion. We have to choose three materials which will be the best or suit for the train brake pads. So the first material that we choose is cast iron brake shoes. The composition of itself is mainly made of steel. Because of the use of steel in the train brake pads, it comes with an excellent friction property at higher temperature under high loads, high mechanical strength, and can be used in the temperature ranging around 400 until 1000 degrees Celsius. But it comes with a wear at low speed in large amount. The thermal stability of steel dual affinity, which can easily produce adhesive bonding and prone to abnormal wear and noises. And the second is copper-based brake shoes or brake pads. As we know, the copper is a very good heat conduct. It can withstand high temperature ranging from 400 until 800 degrees Celsius. It comes with a friction coefficient ranging around 0.35 until 0.45%. And at the use of temperature from 600 degrees Celsius. It shows a very high mean friction coefficient and small fluctuation of friction coefficient. Even though it's a very good heat conduct, it comes with a flaw that the copper base itself is a very soft solid substance because of the copper matrix. And the third materials that we choose is aluminium MMC based brake shoes. MMC stands for metal matrix composite. It is widely known as a material that has been used in train community. The specific heat on this material is 1.7 times higher than regular irons. The thermal conductivity is 5.3 times higher than the SG iron or spheroidal graphite. The yield strength is at the minimum of 153 Newton meter square. The high thermal conductivity of this metal comes with a low modulus of elasticity, assisting in achieving a low stress in the case of thermal input caused by friction braking. Thank you.
Assalamualaikum, I am Ahmad Wafri with metric number CD190142. So, continuing with the discussion, which is comparing properties, we have three materials: cast iron, copper, and aluminium. We have a lot of parameters that we want to compare. First is the wear resistance. Between these three, cast iron has the highest value, with copper medium and aluminium the lowest. With higher wear resistance, it can deteriorate slower and can function well longer. For tensile strength, it is divided into two, which is ultimate tensile strength and also the yield strength. Between these three, cast iron has the highest, can become the highest with the value from 90 to 1650 for ultimate tensile strength and 65.5 until 1450 for yield strength. For the thermal resistance, now is copper with the highest value, which is 456. It can function well in high temperature. Next is the cost. Between these three, copper has the highest value, and aluminium is the second, and cast iron has the lowest value. Lastly is the coefficient of friction in clean and dry condition. Between these three, aluminium can become the highest value between these three, which is 1.05 until 1.35.
For discussion on final selection. On final selection, we will choose the best main material for high-speed train brake pads. The way we do this is that we will give marks for each material based on performance in each criterion. The best performance for each criterion will get 3 marks. For the medium one, it will get 2 marks, and for the poor performance, it will get 1 mark. Adding up all the marks of the criteria, we will choose the best main materials for high-speed train brake pads based on performance of each criterion. So for the marking, for wear resistant, cast iron is better than copper and copper is better than aluminium. So here cast iron has the total marks of 3, followed by copper 2, and then followed by aluminium 1. And then we continue for tensile strength. For tensile strength, cast iron is better than aluminium and aluminium is better than copper. For thermal resistant, copper is better than cast iron and cast iron is better than aluminium. For cost, cast iron is better than aluminium and aluminium is better than copper. For coefficient of friction, in clean and dry condition, aluminium is better than cast iron and cast iron is better than copper. So adding up all the total marks, cast iron have the total marks of 13, followed by aluminium 9, and then followed by copper 8. From the graph here, we could see the graph of marks based on performance on each properties of main materials. So from our findings, we find that cast iron performed the best with the total marks of 13, which is the highest, followed by aluminium and finally copper. With the best score in performance, we choose cast iron as the best materials used to produce brake pads for high-speed train to enhance the friction material reinforcement. With its great performance in wear resistance, which would make it last longer than the other material, great performance in tensile strength, which makes it a great resistance material, medium in thermal resistance, which is good enough to hold heat caused by friction, low cost, which is economically good, and then medium in coefficient of performance, which is good enough to become high-speed train brake pads. So that's all for final selection.
In conclusion, we success to achieve all those objectives which are important in determining the best materials used to produce brake pads for high-speed train, then to enhance the friction material reinforcement by comparing wear resistance, tensile strength, thermal resistance, cost and coefficient of friction on clean and friction of coefficient in clean and dry condition of main materials, and last but not least, we choose the final main materials that has more advantages than the other materials based on our findings. So this study, it is 100% based on journals, internet, books, articles and researchers' thesis. We hope that our research of this study will help in finding the finest friction materials reinforcement that will generate a great high-speed train brake pad for commercial use in Malaysia. So regarding the difficulties in facing this group assignment, of course, due to the MCO, we cannot do our normal meetings and we have to discuss and exchanging the ideas in WhatsApp and Google Meet applications. Also, the study materials that we need to use is very hard to find, and if we happen to find it online, the author did not share their full research, so it is hard for us to find our sources. Some of them just share few informations and it is not all of those related to this topic. We also need to use many platforms in searching the related point for this topic, since this is not actually the hot topic to be discussed among the researchers. It is also hard when it comes to internet problems, because sometimes few of our group members cannot access the internet. Though with all problems that we face, we still managed to finish all parts in these assignments due to the cooperation given by the members. We help each other especially when it comes to internet problems. We were very thankful since all of the members being responsible towards their own part that has been distributed by the group leader. We hope that one day we have the chances to do assignment or probably projects appropriately with an actual test, such as friction test, porosity test, hardness test, and so on. I think that's all from me. Thank you.